Hello, in this video we're going to look at one of the ways that we can multiply two vectors together. And this is what's called the scalar product of two vectors. It's sometimes called the dot product because we represent it using a dot, or the inner product because it's a characteristic of the two vectors' sort of components. It's called scalar product because it produces a scalar result. So I take two vectors, I put them together in such a way that my answer is just a number, no longer has direction associated with it. And it's defined in two different ways. The first definition given here, u dot v, so a vector u times a vector v in this dot product kind of way, is the magnitude of u times the magnitude of v times the cosine of theta, where theta is the angle between the two vectors if their origin points are put together. I can also define it using components. I've defined it here using two-dimensional components, but I could also define it using three-dimensional components. Essentially, if each vector has its horizontal component, its vertical component, and maybe its depth component, then the scalar product is simply the product of each of these components, the corresponding components, all added together. So for 3 dimensions, u dot v would be u1 v1 plus u2 v2 plus u3 v3. Take the corresponding components, multiply them together, add all those up. Since I have those two definitions, that means the scalar product can be used to find the angle between two vectors. So if I say, for example, let's drop back to just two-dimensional vectors here, but still applies to 3 dimensions, u1 v1 plus u2 v2 as one of the scalar product definitions equals the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them, then that means that the cosine of the angle between them has to equal the sum of the products of the corresponding components divided by the product of the magnitudes. So we can use that information. So let's find the angle between these two vectors, again, in 2 dimensions, but the same thing applies in 3 dimensions. So using the components, I can define the dot product as uv equals -1 times 1 plus 3 times 2, or in other words, -1 plus 6, which is 5. So I know the dot product is 5. That means that the cosine of the angle between these two is 5 over, well, the product of the magnitudes. So the magnitude of u is the square root of -1 squared plus 3 squared, so the square root of 10. And the magnitude of v is the square root of 1 squared plus 2 squared, so the square root of 5. The product of those two is root 50. I can simplify this. I don't really need to find the angle, but I'm going to, because this is 5 over 5 root 2, or in other words, 1 over root 2. I could have just used a calculator with the 5 over root 50, but I know that 1 over root 2 is the cosine of a 45-degree angle. So theta, therefore, is 45 degrees. Now, technically, the angle between the two vectors could also be an angle of 315 degrees, but we generally will think about these as being the most direct angle. So if I'm looking at these vectors in their positions, u would be defined by -1, 3, so u is kind of this position vector, and v would be 1, 2, so kind of this position vector. We're mostly going to define theta as being this shortest direction angle and not the one around the outside. But technically, it could be either. They both have the same cosine. And since the cosine of a right angle is 0, that means that the vectors will be perpendicular if the product of their magnitudes can't be 0 if neither of them is 0, but if the dot product is 0, then the vectors will be perpendicular. So that is a way of determining whether vectors are perpendicular or not, determine if their dot product is 0.